Have I shared it yet?
No, you're not sharing your screen.
Okay, hold on just a second. Let me get that shared. So this is what it will say, and I'm just going to do it right now.
Yeah, I might have to refresh my page.
No, it's not in there yet, I bet. Let me just do it. We're going to put this in here. Okay, I've been able to start to update grades. Okay, I've just posted it. Now refresh your Google Classroom and see if it doesn't show up.
Yeah, it showed up right now.
Okay, read it real quick.
It
See if
says, I have been able to start an update grade. Wait, I have been able to start to upgrade grades, homework. I will continue to do so today. If you did not receive full marks, that means a significant portion of one or more assignments was incomplete. Since we are still getting the hang of all of this tech stuff, I will check again Sunday evening around 7 p.m. If you continue missing work, I will give up to full credit, this time only for anything less than 100% in IC. In the future, if I open the gradebook and your work isn't there, deduction. How much depends on how much of a pain in the ass for me. Smiley face.
so if it was a real pain in the butt for me, the deduction will be bigger. If it wasn't that big a deal, the deduction will be pretty small. Because
Oh, okay.
I don't want to kill people for missing stuff. I know you're busy, but the flip side is like if you're not doing your stuff, you're also not ready to participate because you're behind. So
Yeah.
it's kind of that mix, and so it just depends how big an issue it was. John, does that make sense to you too?
Yeah, thank you.
So what I'm going to do is try to get my screen the way I want it so that I can see you guys. Okay, perfect. And then that's fine. All right. So I am going to go. Oop, I want to do this different. I want this to be down here. I want you guys to go into your OneNotes. And you're going to get something double. And if it makes sense to you this time, then on Tuesday, when the rest of the juniors are back, you guys are going to get a chance to practice it and kind of get ahead on your homework. And if it doesn't make sense to you, then you'll get a chance to see it again. Can you see my screen? It's got two different sets of limity things. We talked about the derivative being the limit of the slope equation. And yesterday we talked about this picture on the left. And are you guys the kind of people that like to take notes, or do you like to just kind of watch and listen and think? What is better for you?
I'm good with both.
How about you, John?
I'm also good with both.
Okay. So if you want to draw this picture, you can, or you can just kind of watch me and ask questions and understand it, knowing that the picture is always going to be saved in the content library. So the notes I write, you can always look back at. But what I want you to see is that according to this picture right here, the function we're taking the derivative of, or finding the slope of the tangent, is this f of x equals e to the x. So we're really saying, hey, I want to find the slope of the line tangent to e to the x, and I want to find it at x equals 1, because that's where the tangent line touches the black curve. So far, so good?
Yeah.
Okay. And so if that's true, then this little yellow run is really the distance h, because the next x coordinate is 1 plus h. And that means my run is 1 plus h minus 1. And that, of course, simplifies to what?
Just h.
Just h.
Just h. The ones, positive and negative, cancel out. Similarly, if I'm going to try to find the rise, I'm going to take my function e, and I'm going to plug in the x value to the right. And the x value to the right is 1 plus h. That's my y1, or my y2, however you want to think about it. What is my y1 going to be?
E and then parentheses 1.
That's
E
right.
to the power of 1.
E to the power of 1. That's exactly right. This is the definition of our derivative if we're looking to find the derivative for the function e to the x. And of course, we need this distance h to go to 0 so that it's not a secant line, but it is a tangent line. Does that part make sense to you guys?
Yes.
Yes.
And so this is my equation for the derivative of e to the x at x equals 1. Derivative of e to the x at x equals 1. Now, the next picture is a little bit different. Instead of saying my x values are x equals 1 and x equals 1 plus h, I'm going to say my x values are x equals 1 and x equals some number c. But I still want the same derivative equation. What will be my rise now? And what will be my run now? What do you think? Do I still want y2 minus y1 over x2 minus x1?
Yes.
I do. That's right. So what is my y2? What is this guy over here? I said my x was c. What's my y going to be?
E to the power of c.
E to the power of c. Okay. What then is my y going to be here?
E to the power of 1.
E to the power of 1. And so what's my rise?
It would be e to the power of c minus e to the power of 1.
And what would be my run?
C minus 1.
C minus 1. Okay. Makes sense, right?
Yes.
What is my limit statement, though? What is really happening? Is something approaching 0?
Will it still be x goes to 0, or?
So let's look at what's happening. As I get closer and closer, this red dot moves down the curve to that blue dot, and then to the dark blue dot, and then maybe to a dark green dot. All those values are C, aren't they?
Yeah, so it's as x approaches c.
Almost. It's as C approaches what? When it gets right on top of the red dot, where will C be? What will the x coordinate be for C?
Would it be
1.
Yeah. It would be 1.
wait, why is it 1?
Because that's where we want the exact derivative at x equals 1.
Oh.
If I get those red, light blue, dark blue, green dot, if they move farther and farther in, eventually they'll get right at 1. So when C approaches 1 exactly, like if they were ever exactly the case, right? If C ever became exactly 1, wouldn't I have e to the 1 minus e to the 1 all over 1 minus 1? And that, of course, would be trouble, wouldn't it? Because what does 0 over 0 mean? You remember the vocabulary word for that sucker? Indeterminate form means we can't do it yet. But because we have the limit statement, we can get as close as we want to without quite getting there. And that is our derivative. We get so close that we are imperceptibly close, but we are not right on top of, otherwise we have indeterminate. That's what's happening. So do you see the similarities and the differences between these two equations? Because they both represent the derivative of e to the x at x equals 1. What are the similarities?
Wouldn't it be, well, don't both of the equations, like if you use them, they're both equal to them?
Yeah, I mean, they both mathematically work, right? So they both work with math. That's one similarity. There's one more I can see of. Actually, there's two more. They're both in fraction form, aren't they? What's the other main similarity? I'm going to highlight it.
Wait, the limits were the same?
Well, they both have a limit statement, right?
Oh, they both have.
They both have a limit statement. Now let's look at the differences. What's one difference?
The limits aren't the same.
Yeah, the limits aren't the same.
The second one was indeterminate.
Well, they're both kind of indeterminate.
Oh, they were?
If you let h really go to 0, like if h really goes to 0, we'll have a 0 there, we'll have a 0 there, and we'll still get e to the 1 minus e to the 1 all over 0. Well, that's also
you're right.
0. See how like they both work out to be indeterminate? But that's not what I was thinking of. One difference is the limit statement is different. One of them, h approaches 0. The other one, x or c, approaches the number. We take the derivative. You see how all of a sudden when I look at the second one, I know I'm looking for a derivative at x equals 1. I can tell that. Whereas the first one, I can also tell that I'm looking for x equals 1, but that 1 shows up somewhere different, doesn't it? For the first one, I'm going to have an f of x plus h. Whatever this number is, if I have 1 plus h, that means x equals 1. What do you think? Sort of understand or not?
I think I'm getting the hang of it, kind of.
And so what I want to do is I want to apply both definitions to a practice problem. Let's see if I can find one. Yeah, let's look at this one here. Which definition, let me label these. This first one is the definition. And the second one is the alternate definition. Which one, the definition or the alternate definition, matches this problem C?
The alternate definition.
Yes, tell me why.
The limit is approaching something that's not 0, so it's approaching -2, and then it seems to have f of x minus f of a over x minus a.
It sure does. Yeah, I mean, it's not, this isn't a 0, and this isn't a 0. Whereas if it was the main definition, both of those h's would be 0, wouldn't they? And so if we can figure out, like we're really trying to figure out, hey, what is f of x equal to, and what is x equal to in this form of the derivative? If I can write it down as we're really looking for the limit as c approaches some number, and then we've got f of c minus f of our number all over c minus our number. Can you guys tell what the number is?
2.
Almost.
No, -2.
Yeah, -2. Notice, like that's a +2, isn't it?
Yeah.
But what that really means is x minus a -2. So -2 is really my number. What's the function?
Probably cube root x minus 6.
How could we check ourselves to make sure that's right?
If you plug it in minus f of a. Yeah.
Like if you plug in that -2 for x, right? What are you going to get?
You're going to get, wouldn't it be -2?
Well, wouldn't it be -2 minus 6?
You should get the minus f of the number.
Yeah. What is -2 minus 6?
negative 8.
Does that
And
show
then
up?
cube root that.
Mm-hmm.
Oh, yes.
So yeah,
It does show
that's
up.
right.
So that shows us that what you see for f, that's really asking for the derivative of y equals cube root of x minus 6 when x equals negative 2. That's what this limit statement represents. Now I have to check something. We started at what time? 10:15.
So we have like 10 minutes left.
No, we only had 25-minute classes today. So
Oh, really? Oh,
what's 20 plus 15?
20 plus,
That'd
wait,
be
20 plus
35.
35.
So we go to 40. So we're like
So
2
2
minutes
minutes.
away. Oh, bummer, but that's okay. Take a look at D really quick. Which definition do we want for D?
The first one.
Yeah, this is the main definition, not the alternate.
Wait, for a test, will we have to be able to tell, like, do we have to write that down? Like,
So what I'm not gonna ask you, is this the definition or the alternate definition? I wouldn't ask it like that.
okay.
But I would ask, what does this represent as a function whose derivative we want at a point? And I would want you to be able to figure out, oh, which one do I need to use? You don't have to know that it's called the main definition or its alternate, but you do need to be able to pick out, like the last one, hey, I know what f of x is, and I know what x is. So do you think we can do that here real quick?
Yes.
What do you think, like as you're thinking about f of x and making some possibilities, what might f of x be and what might x be?
Would it f of x be 1 over h ln?
Maybe, let's write that down. 1 over h ln of what?
Of x over 6? Wait, no. One h.
Do you know what x is?
0? Or would it be 6?
I think it's got to be 6. Because in this case, this is where our h is going to 0, isn't it?
Yeah. So would inside the ln, would it be x over x?
Well, we know we want, when we're all done, this is where we kind of want to go back to our main definition. Hey, we've got f of x plus h minus f of x
Over
all over h, right? That's what we're trying to match this to.
Mhm.
And we've got the h approaches 0. That looks good. And we've got 1 over h ln of something, but where's our minus thing? And where's our h?
Oh.
And we don't, like, we wouldn't have to, if h, it's like this really should be a 0, right? And that's not going to show
Yeah.
up. in our, like this h approaches 0.
Mhm.
I think that might be this right here. I think we might have factored out that 1 over h. So I'm not sure that our function is going to have ln in it, or a 1 over h in it at all.
Could it be that it's just one ln as the f of x?
Okay, it could be ln of just something, ln of x plus h, that would be the numerator, right?
Yeah.
Where's that 6 coming from? That's the sneaky part.
Can't you just cancel those 6's out?
You can't because of the plus sign.
Oh.
And you guys have to get to your next class. I would say let's wait and pick up here on Tuesday. But what I want you to do is just see if you can finish this one problem. Just try, see if you can get to where you know what f of x is.
Okay.
We know x is 6, so we're really just trying to figure out what the heck is f of x. Chew on that, do any missing work for Sunday, and we will meet again on Tuesday.
Okay.
All right.
Okay.
Bye-bye, Mr.
Have a good day, sir.
Good job today, guys. This is tricky stuff, but you're doing great.
Thank you.
Bye.
Bye, guys.
Bye.